Well, hi, good morning, and thank you so much for coming here to keep me company while I work on this radio. Today, it's another nice day outside, very cool, 23 degrees, but tomorrow the heat wave comes and it's going to be 32 here, high humidity, so a dramatic change in the weather is going to come. It's going to be like 4 days of steamy weather. Same hot air that's been floating around the States. Is finally making its way up into this area. So what I want to do today is replace the last two, I think it's two, wax capacitors. I'm just looking for them. One here. And wasn't there another one? I think there's another one in here somewhere. And thank you very much. I got a few emails from those of you taking pity on me because I've only got a one-page schematic, and you know where the two-page schematic was. It's on Pacific TV. I believe that's where it was. Maybe I'm wrong about that. Not Pacific TV. Thank you very much for sending me those links. And one of you sent me the actual schematic with both pages. The second page is a write-up for it's a parts list and a write-up on the alignment of the radio. And the engineer who wrote it very, very carefully. So I want to go through that today. Maybe not actually do the alignment. We'll save that for tomorrow. But go through the alignment instructions and the interesting things that this engineer has put in his instructions. He really knew his stuff. So first thing we're going to do then is, there's the other capacitor up here. 1 and 2. So this one conveys the output of the volume control on to the amplifier. If it were not conveying, there'd be no sound coming out of the speaker, so we know it's working to some degree. Okay, so I'm going to nip that off and replace it here. I have the parts list now, so I can't read the value. Ooh, look at this. So this is the battery, bias battery. I'm just feeling to see if the spring clip is really pushing on it. It is, even though the whole thing is loose in here. That sounds like you just cut two things. That sounds like two things getting cut there. Wow, dark. Oh, where'd the end of the capacitor go? It stayed behind. Where did it go? Well, that's why it sounded like two things when I cut it. I think what must have happened is the wait a minute, this was like this, wasn't it? The lost end has come from here. Where'd it go? They fall into the radio. Big piece of ugly aluminum in there. I don't think so. Well, wait a minute. They can't just disappear like this. It didn't evaporate. Well, what happened to it? Oh. Time for some new batteries here. Oh, I think there it is. No. Let's look with the other camera because I can't see with that either. Okay, so before we look through that other camera, I am going to freeze the focus on it, so just bear with me a moment. Because the autofocus is a terribly annoying thing because it's so slow with this camera. Okay. Let's switch cameras here. Go looking. First of all, here's the capacitor. Well, you know what? It looks like the terminal end is still in there. Look at the gap inside. This is quite something. So the wax has leaked out, and it's full of air in there. You can see the lead wire where I'm pretty sure that's where I cut it, because this was up tight on here. So what happened to the wax end of it here? I mean, did it melt away? Did it falling in here somewhere? I don't know. Huh. Well, if it's just the wax end, we don't have to worry too much about it, because that resistor looks like it's been replaced. Kind of weird how it's done here. Why the piece of wire like that? And then the wire I cut, I think we're looking at the end of it up there. And get it onto that terminal. That resistor looks pretty sad. There's a lot of dirty, sad looking parts in this radio. Okay, you can see the value right away on it, 0.01. Okay, I'm going to replace that. I guess we don't need to test this. It wouldn't be worth it. Wow, look at that. So this is what's inside these capacitors. Are they not full of wax? They wouldn't leave them just full of air like that, would they? I think the ones I've taken apart, the paper inside is just butted right up against the outside shell. There's no gap. But I guess at the end here you could get some kind of a gap happening. They want to put the wax in there to push the air out. Okay. Anybody keeping track of how many times I say okay in a video? It's quite a few. I'll put in a new 0.01 and then we'll go after the other capacitor. Yeah, I spotted something interesting while I was putting the capacitor in. Have a look. So here's the battery. Okay, but look at the terminals underneath. You see a wire that looks like it's been soldered across and then cut later. So my thinking on this is, at some point the battery was dead, and one thing you can do is just short out the battery and forget about it. Just do away with the bias and carry on. And it looks like somebody did that. They just soldered a wire right across. Well, then later somebody's come along and cut the wire. Maybe because they had a replacement battery at that time. But you can see the condition of this battery. That's the rubber seal going around the carbon button, and look at it, it's just, most of it's missing. So there's no moisture seal whatsoever. Now you can throw some water on this. Some of it might penetrate and it might bring the battery back to life for some period of time, but it wouldn't be very long. So the radio operated the way it is now. I don't think I'm going to reinstall the short there. I'm just going to leave it the way it is. It's a piece of history now. And this is the terminal I'm trying to connect to here. It's very hard to get at. And pretty rusty. Must be a steel piece up in here somewhere. Looks rusty anyway. Maybe that's just resin and stuff like that. Anyway, thought I'd show you that what I think is more history for this radio. The battery has been worked on before by somebody. Would be two people, or would somebody have put a short in there and then decided this isn't working and then cut it? How would it not be working? Okay, got the new capacitor in. I'm going to give the radio a quick test here, just to be sure. We're hooked up to an antenna. I can't remember if I switched it on or not, but really we just need to know if the radio can operate. Shortwave.
Now I've printed off a number of verses here to save time, so just passing that through to you there. Can you just take a look at that?
No, we can't take a look at that right now. Okay, so the next thing is this capacitor, and then I think that's it for wax capacitors. There's a lot of molded ones, which is really just a tricky form of wax capacitor, but let's check. We'll just do this last one. In fact, before I stop, why don't we cut it out? Cut it out now. The back terminals, very hard to see, especially with a light so low. Way down there. Okay. So this one looks to be in pretty good shape. It's a Philco 0.001. Now this looks really well sealed. Working voltage 1200 volts. So this is probably across the output, or something to do with the output transformer. That's where you find these high rated capacitors. And frankly, 1200 volts, where's that come from? In a radio like this. They wouldn't put this in an expensive capacitor. They wouldn't put this in the radio unless there was a good reason for it. And I've encountered these quite often. Very high voltage capacitors. I think always in the same position. I'll bet you this one tests good. Let's find out. You think if it's made for 1200 volts, it's made better. Let's see. Okay, so 50 volts. Try my new iPod position, or tripod, not iPod, tripod position. There we are. Okay, we're going to hit the switch here. 50 volts. Oh, what happened there? Well, what did I see? Make sure there's making contact here. Try it again. So there's something weird going on here. For this size capacitor, and what is it? Yeah, it's a small one, maybe. We should see it close and open. It's going really fast. Like you don't see it close at all. So that's 50 volts. This will probably keep it closed at 150 volts. So it's not in great shape. A little bit leaky. Let's measure this one on the on my super smart device here. What I find is when the capacitors are leaky, they tend to measure high on the capacitor checkers that I've used. Various checkers. This one uses a complicated technique for determining capacitance. I think anyway, it's complicated. It uses frequencies and I don't know what all. I really don't know how it does it. So this thing says it's 1700 picofarad. That would be a 0.0017. And it's supposed to be a 001. So I think the added 7 is due to the leakiness of the capacitor. So it doesn't test all that bad. V loss 0. That's kind of suspicious, isn't it? Okay, so 0.001, I will put it in. I'll put it in the radio. Okay, let's give it another test here. Power on. So I've got this connected to my outdoor antenna, but you know what? I don't know that I've got the antenna switched on down here, actually. Got to think of it. but it seemed to pick something up. Let's see what it does now. There he is.
Because Judas had some money that Yahusha had said to him. Eat for the feast. Or something to the full.
I think this bigger knob should be on the tuning. Okay, so it radio's operating. Perfect. That's all we need to know at this point. Now we're going to look through the schematic. The last part of this video will be looking through the schematic diagram, more the information that has come for this radio from the very smart engineer who wrote it. Let's take a look at it. Okay, so here it is. 34C, this is the schematic I've been using. It's the same diagram. There's nothing different on it. Okay, but this is the page I don't have here. Adjustments, which we would call alignment, general instructions, and general notes, and a little bit up here, and then a list of replacement parts. Okay, let's start with this. We're going to read through this. Some of this is kind of standard stuff, but some of it's a little interesting. This receiver was carefully aligned and adjusted at the factory. No one but a serviceman experienced with short-wave receivers should attempt to realign the receiver. An oscillator with frequencies of those should be used. In addition, an output meter should be used across the voice coil or the output transformer for indicating maximum response. I think they're saying don't try to measure the AVC voltage, which is a technique I use. Back when this was written, the engineers realized that the servicemen had lousy equipment, lousy meters in particular, which drew a fair bit of current from the circuit under test in order for the meter to operate. In drawing power from circuits can throw them off. And that's why they were saying put it on the voice coil, because a lousy meter, there's lots of power on a voice coil, lots of power for the speaker, can drive your meter no problem. Alignment procedure. Set variable condenser to minimum and turn waveband switch to broadcast clockwise. Thank you. Introduce a 456 signal on the grid of the 6AA tube. Adjust both trimmers of the two IF transformers to maximum deflection on the output meter. That's normal. That's a routine thing. Remove the 56 kilocycle signal from the grid and feed it through the antenna. Adjust the 456 interference trap trimmer for minimum response. Now I'm really interested in this. I had a radio go by just a couple of radios ago, also had a trap in it, an IF trap, but I didn't realize that. I didn't have a schematic, didn't have any information. This is an interesting feature. We're going to fool around with this when we get to it. The trap trimmer is at the rear wall beneath the chassis deck. Yeah, it's actually kind of inside the chassis. With the pointer at 600, feed 600 through the antenna, adjust the broadcast series pattern. Headless set screw closest to front. He's being very specific on where things are here. Move the pointer. Okay, so this is just standard stuff. This is all standard stuff here. We don't have to read nothing interesting in here other than just instructions for doing the alignment. General instructions. Always choose the minimum capacity peak on oscillator trimmers and maximum capacity peaks on antenna trimmers. The last motion in adjusting a trimmer should always be a tightening one, not a loosening one. Now there's an interesting little piece of stuff there from this guy. Always be tightening your trimmers, not be loosening them. Well, I certainly have paid no attention to this rule in the work I've done. I tighten or loosen, and I haven't paid any attention. From now on, I'll do what this guy says. I'll try to remember to always be tightening a trimmer. Now, why would this be? Could be a little like a guitar string. On a guitar string, you should also always be tightening it on the last motion because the strings stick in various places. And loosening it, it's better to be tightening it. Okay, I don't know, guitar string? Never leave a trimmer with the outside plate so loose that there is no tension on the screw. Either bend the plate up or remove the screw entirely. Loose screws are a source of noise, frequency drift, and microphonism. Oh, really? Okay, that's another piece. I didn't know that. I've certainly turned some trimmers all the way up to the point where the screw isn't contacting the plate anymore. Never thought much about it. Okay, thank you, Mr. Engineer. That's very helpful. Now, you think the guy who wrote this had any idea that someone like me and you would read this stuff in the year 2024 and say thank you to him? No, no. You couldn't have imagined it. In aligning antenna trimmers on the high-frequency signals, there is usually a tendency for the oscillator to drift due to interlocking. Interlocking. I've never seen this term used in this way. To compensate for this, always retune the variable condenser as you align. That's in aligning antenna trimmers on the high-frequency signals, there is usually a tendency for the oscillator to drift due to interlocking. What's it interlocking with? To compensate for this, always keep retuning the variable condenser as you align. Well, I've never seen this instruction. I've certainly seen the rock the condenser. That's a different process. That's a hunting process, hunting for the sweet spot. This is something else he's got here. General notes. The receiver should never be turned on with either the speaker plug or the 42 tube out of its respective socket. And then he explains why. Since the rapid rise in rectifier voltage will damage the electrolytic condenser. Oh yeah, well, first of all, rapid rise damaging an electrolytic condenser? Never heard that before. I've just never heard of such a thing. How that would even happen, I can't imagine. But there it is, written here. Never thought about this. I've operated radios with the speaker plug out. Never thought about rapid rise of the B+ damaging anything. Basically, when you pull the plug out, there's not much hooked up to the B+. Just one condenser. I would say what you'd be more concerned about is the voltage rises much higher than it would normally. And that higher voltage might damage the electrolytic condenser. But he says rapid rise, and I can't argue with him. Number 2, bias for the grid of the audio section of the 75 tube is obtained by means of a very small 1-volt battery. Do not put a voltmeter across this bias cell. Check it by temporarily replacing it with a new cell or some other 1-volt source and noting the results. To remove the bias cell, simply pull up on the spring clip and lift the cell from its cup. Cell assembly is mounted on a bakelite strip on the inside of the right-handed chassis wall. Okay. When replacing the cell, make sure the clip makes good contact. So just do not put a voltmeter across this bias cell. Now, he didn't put it in bold print, but I'm reading it as if it's in bold print. I think what he means here is don't waste your time trying to read the voltage with your junky old voltmeter on this cell, because you're going to see 0 every time. The cell cannot produce much current. So not enough to operate your voltmeter, mister. Don't put the voltmeter across this. And I know you, Mr. Repairman. You got the junkiest voltmeter and that's all you've got. You're all the same. So don't any of you try this, because you're going to find every bias cell is dead. Of course, you're going to sell bias cells. Way to go. But that's not going to fix the radio if it's in your shop for a repair. Pilot lights may be replaced by slipping on. That's nothing. Nothing interesting there. There's nothing more interesting. The interesting stuff I've gone through. So I thank this particular engineer for having written a few things in here I've never heard before. Maybe it's just me. It's the first time I'm encountering them. Interesting. Sometimes I'm very frustrated when I read the instructions. They've been not been written with much thought, and other times I read things, you know, the engineer is putting everything he's got into what he's writing here. So thank you again. Now back to the camera. So as I said at the start, it's a beautiful day outside and I should not be in here, so I am done for today. Tomorrow we will try aligning this radio, even though it's operating quite well. There might be a little more to get out of it. And I think we'll be done. Amazing, eh? It's amazing. I really thought this radio was a dead dog right from the start. But no. Thanks a lot for watching, and have a great day.